This is another iRaw podcast.
Restricting your wavelength is better than not restricting your wavelength. So just saying, oh, no matter what, there's someone that's going to be affected by this, we'll just do white light. No, don't do that, because now you're going to be affecting everything. But so yeah, go with an amber. And when the fireflies are coming out, turn off your lights, right? Don't have any lights when the fireflies are courting.
Hello everyone, and welcome back to the Animal Turn podcast. This bonus episode is going to be a cross-post episode. In fact, it's not my content at all. Today's episode, you're going to be delighted with a different podcast. Perhaps you know it already, the Deal With Animals, hosted by Marika S. P.L.E. If you don't know the podcast, make sure to go check it out. It's also part of the iRaw network. And Marika and I, we have had several overlaps over the years in terms of different guests that we've had on our respective shows. So I have no doubt that you'll enjoy her content. Now, the episode I'm sharing with you today, Marika suggested, and I listened to it, and I thought it was really interesting and fascinating. And it's something we haven't dived into great depth on the Animal Turn yet. And that's sensory pollution with Dr. Brett Seymour and Dr. Jennifer Phillips. Now, sensory pollution is everything from light pollution to sound pollution. And these two guests join Marika on the Deal With Animals to talk about the ways in which this pollution impacts animals and some of the ideas with regards to what we can and should do about it. This is episode 2 of Marika's series focused on anthropogenic behavior. So it's very ecological. Sometimes it's a bit technical, but it's always interesting. If you haven't followed and subscribed to Marika's show already, make sure to go and find it wherever you listen. And if you have a spot of time, why don't you head over to your favorite platform and also leave it a review.
This is the Deal With Animals. I'm Marika Bell, anthrozoologist, CPDT dog trainer, and an animal myself. This is a podcast about the connection and interaction between humans and other animals. Second episode of our Anthropogenic Change series, we're talking about sensory pollution with Dr. Brett Seymour, an associate professor at the University of Texas at El Paso. His research interests include how animals interact with their visual environment and how light pollution disrupts natural behaviors, physiology, and ecosystem services in arthropods and their predators. We're also joined by Dr. Jennifer Phillips, an assistant professor at Washington State University, one of my alma maters. Jenny's research focuses on animal behavior communication and the effects of human activity on wildlife, especially passerine birds. Specifically, she's interested in how functional traits are affected by landscapes and sensory pollution, and whether changes in these traits lead to population and community-level ecological consequences. I think you can already see where this is going. In this conversation, we're going to get to talk about bugs and birds. Specifically, the impact of everyday lights and noises on insects and bird ecosystems. We're going to find out why insects are attracted to light, talk about legislation efforts to protect wildlife from sensory pollution, what wavelengths of light are more beneficial for wildlife but also have our own health benefits, the importance of the light-dark cycle, and how to start protecting more urban green spaces from these types of pollutions. And then we're going to get into spider personalities. So listen all the way to the end. I think you're really going to like this one. Thank you for joining me as we ask the question, what's the deal with animals? Welcome to the podcast. Brett, would you like to go first since you were first online here? Introduce yourself, and I invite you to please share your pronouns.
Yeah, so I'm Brett Seymour, he, him, his, and I'm an assistant professor at the University of Texas at El Paso, in El Paso, Texas, obviously. I study the effects of both natural light and artificial light on animal behavior and visual systems in myriad organisms, but I'm really focused on arthropods, specifically insects and spiders. My greatest interests are those with moths and wolf spiders, but I do like I do like studying everything, and we study the predator-prey interactions. So we look a lot at birds and other animals that could be our insects and spiders. Current projects that we're working on right now is looking at how both natural light and artificial light affect the behavioral variation of wolf spiders, what some people might call personality. And I'm doing air quotes as I say that. I don't really like the term personality, but you can get the point. And we're also looking at how both natural light cycles and artificial light alter the movement of a lot of animals, especially big hawk moths or spinged moths. And then lastly, I have a new project that's starting with one of my graduate students where he's going to be investigating the effects of urbanization, again, mostly light pollution, on these crepuscular bees where they fly during the day and at evening, right, during dusk. But the flower doesn't open until dusk and then closes in the middle of the night. And so we're testing these hypotheses that are surrounding this idea that perhaps there's going to not be the same gap where the bee can actually be pollinating this flower because the flower might not open in time for the bee to get it under light pollution. So these are some of the projects that we're working on. I'm also heavily involved in trying to understand insect declines, and I'm working with a big international group on insect declines and light pollution.
Oh, that sounds super fascinating. Okay, I can't wait to get into that conversation. All right, and Jennifer?
Hi, I'm Jennifer Phillips. A lot of people call me Jenny, and I am an assistant professor at Washington State University in the School of the Environment. So my pronouns are she, her, hers. So I broadly would call myself a behavioral ecologist or wildlife ecologist. But like Brett, I'm mostly interested in the effects of sensory pollutants on animal behavior. And my area of focus is usually on bird behavior. And I'm very interested in trying to understand how these behavioral changes we see in birds scales up to these actual fitness consequences. So are there actual consequences to changing a song because of noise? Or is there a consequence evolutionarily due to being in a lit environment? And so there's lots of different scales we can look at that. And then also I'm starting to look at the physiological side of what's driving these behaviors as well under different light and noise regimes.
All right. Fascinating. We got a great conversation for today, I can tell. Let's start with insects, because I have a lot of questions there, just thinking right off the bat, in terms of our very personal individual choices about leaving our porch lights on, or Christmas lights, or just in general, these sorts of everyday lights that people just think my light isn't going to it isn't a problem because there's other big lights that obviously much bigger problem. So what would you say to that?
All lights matter. I say that because, especially with insects that are on such a small local scale. So you could have specific insects that are in your hedge, right? Or in your grass even, or in your leaves that you haven't raked up, which is good. Don't rake up your leaves during the winter, right? That's good for insects. They're all there. And so your one little porch light could actually be altering your local community of insects. You're also not wrong to think that there are bigger issues with light, right? Oh, I live in a big city. There's all this light that's going up into the atmosphere, and it's scattering, and it's traveling hundreds of kilometers away from the city. That's also true. But that huge glow of light is coming from the accumulation of all the lights that are in that city. So you can literally reduce that huge growth of light by turning off one light, right? It's simply additive. So even one light is going to make a difference. And yeah, it's a huge, overwhelming problem when you think of the millions of lights that are on in a city. But even just cutting off one or two of them is going to be beneficial to insects, especially at the very local level.
And I would assume that something that's beneficial to insects is going to travel up and out from the food web in terms of what other animals it affects, like the birds, Jenny.
Exactly. Yeah. So, when you see these clusters of insects being trapped by light, it can attract birds and bats to come and feed at these lights as well. So in one respect, it could be beneficial if they're getting extra nutrition from this food source for the birds or the bats. But it could also be that they're spending more time foraging when they should be sleeping or doing something else. So that's one of the major questions. Is it a cost or is it a benefit when we start scaling up these food webs? And it can be both. One of the studies I've done is we put radio tags on bluebirds and we looked at their activity patterns to see if were they potentially staying up later in these lit areas or getting up earlier. And we're not seeing any differences in what time the birds are going to bed. So they don't seem to be staying up later to pick off insects at lights or anything like that. But they are getting up earlier, especially in sites where there's noise and light combined. So it seems more like a disruption in potential resting times of day, or potentially even sleeping or even the rates of incubation. So a positive benefit, but I haven't seen that in my studies so far. So there's still a lot of unanswered questions out there, but there's certainly effects of these lights at night. And it
Getting
is
up
cascading
too early
through
sounds like my house with my little kids too.
Exactly, yeah. These birds their schedule's being thrown off. So yeah, there's all sorts of things. It might not kill you, but it's certainly potentially more stressful.
Yeah, which then leads to all sorts of other problems, I imagine, too, and including behavior change, right? Because when you're stressed, not just you, but when an animal is stressed, it's going to change its behavior. It's not maybe going to be as efficient at doing what it should normally be doing.
Exactly. Yeah. The stress hormones are increased. So they may be just less aware if a predator sneaking up on them, could lead to fitness outcomes in that respect, or just less effective foraging. There's all sorts of potential effects that could happen because you're not getting enough rest.
So let's talk a little bit about what does a light actually do to the insects? I think this is one of those age-old questions. Why do they go towards the light, right? I was trying to answer this for my daughters recently, and can't they tell it's not the moon? You know, that was what I was always told, is maybe they're traveling because they think it's the moon. And my daughters decided the insects are dumb. But I don't know. Is that true? Is that what's going on here?
I won't take the bait on that one about their intelligence. But I will say that we actually just had a wonderful paper published, and by we I mean science. The community of science has just had this wonderful study come out, and it was done by a couple of colleagues of mine. And what they found is that a reason a lot of these moths are flying to light at night is because they have this physiological mechanism where they're always pointing the back of their body, the dorsum, to the light source. And so they're always orienting their back to a light. And so if that light's really close, they're going to constantly get closer and closer and do basically a circle around the light until they're very close, at which point they're just going to fly down and hit the ground. And that's what a lot of moths do. Now that answers the question of how they're doing it, right? So we know that they're basically trapped by this physiological mechanism in which they're always orienting their back to lights. We don't fully understand why they've evolved this. Of course, it makes sense that if you're orienting to the moon or perhaps the brightest part of the sky, then it makes sense to always have your dorsum or your back pointed to that brightest part, which will be the top of the sky, right? So the moon or the sky, that's usually the brightest point until we started to put out artificial light sources. And now they have to contend with these artificial light sources that are brighter and closer than the moon in the sky or just the overall brightness of the sky, which would have been Milky Way when the moon's down. And so now they are orienting their back to these light sources that are only a few meters off the ground, and they're getting their movement completely disrupted. So we did, and that just came out. That was, I think, published 2 weeks ago. So this is a very new, exciting study. And so it's an innate behavior, right? It doesn't really have anything to do with learning. The insects can't really unlearn it. Perhaps selection will start to alter this behavior. And in fact, we do know that there are some populations of moths that are in cities that have lost this. Right. Whereas their counterparts, same species, same individual, the same species, right, outside of the city will continue to fly to lights. But the ones that are in the city, you could say they have like, street smarts, and they don't fly to lights anymore. So this can be lost.
So they aren't dumb. They simply have an innate mechanism that they can't unlearn that orients their back towards the brightest light source in a dark night. This helps them fly straight. It actually makes so much sense. But when our porch light comes on, this innate behavior tilts their body down, pointing their nose towards the ground and their tail towards the sky. Their senses get confused, and they fly in what is essentially a death spiral into the ground, get back up, and then do it all over again, trapped there until the light turns off.
Exactly. Yeah.
Okay.
Almost just like a nosedive. So then you want to keep your back, here's the light, and just dive down.
Diving down, yeah.
So they're drawn to the light because of this mechanism. It's not that their eyes are focused directly on this light and they're just flying right towards it.
Right.
But instead, it's more of this, being drawn to it. And that's what's going on with a lot of insects as far as we can tell. But not all insects are attracted to light. There's actually plenty of insects that are photo negative, right? So they'll actually go away from the light. But of course, we always think of all the ones that are flying around the lights. And
those are the ones that we see. Yeah.
Yep.
Okay. So is there a certain time of day that everyone should then turn off their lights? Is there legislation in place to try to make this sort of thing happen and create awareness around it?
The legislation to protect insects is very, very minimal. They're not actually protected by Fish and Wildlife. There is some legislation trying to get insects added to that to protect them. But currently, there's no protections for any insects unless they are listed as an endangered species. And then usually that's very, very localized. And again, we mostly only really list very charismatic insects. So butterflies and some grasshoppers and stuff, right? Things that people really like. But a lot of things are not listed as endangered. And we also don't have the data to even show because we haven't been able to track them long enough to even know how their populations are faring over time. But as far as local legislation or statewide legislation for light pollution and insects, that's usually not the concern. There are plenty of places that have legislation for light pollution, and it's usually been the focus for astronomy. So a lot of places like Flagstaff or Tucson or some areas in Idaho or here actually just south of us down in the Big Bend area, there's legislation, but it's to protect those observatories that are there because light pollution also affects the ability to send our telescopes right out into space and actually get the signals from stars. So if you have a bunch of light pollution, you just can't study astronomy. So a lot of these laws are actually focused on making sure that light's not going up into the sky. And these cities are pretty impressive, right? They seem much darker at night, even though they still have streetlights and everything. It's just they have all these cutoff fixtures, so only light's going down. They have specific wavelengths of light that are less likely to go up into the environment, be scattered more. But that's usually where the legislation is going. It's actually from a human perspective for astronomy. Of course, the National Park Service is working on this.
Jen, do you think it's more likely that we'd be able to get legislation for that sort of thing because of birds then? Birds are generally considered more charismatic than insects.
Yeah. I mean, definitely people are paying attention because of light's effect on birds. Birds, we think, are semi-attracted to light at night because they're using it during migration to navigate. So they use stars and day length cues to start making these long distance movements. And so what happens with birds oftentimes if they're migrating through high light pollution areas is they get sucked into these cities and especially big skyscrapers and then end up hitting these skyscraper walls and dying. And so this has happened in these mass casualty events quite a few times across the country in different cities. Of course, people love birds, and there's the Audubon Society and all sorts of bird societies. So Audubon has actually started this not international, but at least across the United States, this Lights Out program. So during high peak times of bird migration, they'll work with cities to make sure cities are turning lights off in these downtown buildings, at least to a certain extent. So that's not necessarily in legislation, and there have been bills proposed to try and make this actually part of the law, but I don't think any of them have succeeded yet. So there's definitely effort through bird conservation groups to try and make this legal on paper. But to my knowledge, none of them have gone through yet.
You talked about a few mass casualty events for birds. I haven't actually heard of any of these, except maybe I feel like there was something with the World Trade Center lights that come on.
Yeah, that's one of the main examples. When they built the 9/11 memorial, it's basically two huge light beams going straight up into the sky. So birds were just basically getting trapped in this these beams and flying around and becoming exhausted. So yeah, that's a major one. So I think they have stopped doing that now, at least during migration.
They still do it. It's just that they turn them off. They have them on for, I think, like 15, 20 minutes. They have people counting the number of birds, and either they turn them off like every 15 minutes, or if the number of birds that starts flying in that light reaches a critical maximum, they turn them off for like 5 minutes. So all the birds can then be released.
I wonder how well that actually works, and they just fly right back again. I don't know. It seems like one of those things that when it was being built, somebody could have thought of it if the right person was on the job and the planning was put into place. But it's just not, again, we look at things from that human perspective. We don't really look at it from the perspective of the animals that it might be affecting, even enough to think about asking those questions. So what are some of the questions that people should be asking when they are building in the city or even outside of the city?
There's been a lot of study on this, on like, what can we do for, I mean, certainly with new buildings, we should automatically be putting these types of things in. And oftentimes that still isn't even happening. But so having these dots or lines, vertical lines that are somewhat see-through, so you can still see out your windows, but birds can actually detect these glass windows, helps a lot. So there's been multiple studies showing that, and there's recommended distance between the dots. So like, you've probably seen little cutouts or silhouettes of birds on windows. And that was kind of an early attempt to try and reduce window collisions for birds. But studies haven't really supported that that's very effective, because they're often too far apart. So it's only like 2 inches apart, these dots, I think, about. And I can double check those numbers, but is much more supported by the actual data, where they've had a certain number of window strikes, then they put them up. You see a bigger reduction in window strikes in these areas.
So something can be added after the fact?
Yeah, so they can be added. So there's basically like stickers, or when you put UV protection on your car windows, it's like a layer you can add onto a window that already exists. Right. So for older buildings, you could certainly retrofit your building. It just comes down to whether people are willing to do it and pay however much it costs for those stickers.
Oh, and the idea of having something block their view also is so huge for people, right? Like, well, I would do it and I want to help the birds out, but it might not be as nice to look through for me. So
yeah, it often comes down to, are humans actually willing to take a tiny sacrifice of their perfect clear view? But you can still see through them. So it actually makes a pretty cool looking pattern. So yeah, it's just getting used to something different.
That's a good way of putting it. We just got to get used to the fact that it's a little different, but it's not necessarily worse. So I was able to find a bunch of information about retrofitting windows at allaboutbirds.org. It's a fantastic resource and gives tons of details about different ways to make your windows safer for the birds in your neighborhood. I'll put the link in the show notes.
Yeah, like I said, Fish and Wildlife Service, any of their new buildings or buildings are getting retrofitted to protect birds and to keep lights off at night and that type of thing. But that's just a very small portion of the amount of buildings that have lights on at night or have a lot of windows. So usually it's not government buildings that are the hugest part of a downtown ecosystem.
Right. Yeah, it's all of the other buildings and lights. And Brett, you were mentioning that there were certain wavelengths that were less attractive or they couldn't see them. What's going on with certain wavelengths that would be better for animals? Is that something that we can detect?
There is a lot of information out there about this. In fact, I would say when I started in this type of research, I was all about the different wavelengths of light. And being a visual ecologist and studying how different animals have different perceptions of light, it makes sense. However, the biodiversity on this planet is immense, and all the different wavelengths of light are important. That just depends on who you're asking, right? Especially with insects. So I no longer think that being able to just tune the color of the light is the most important step, because we do know that in general, right, for insects, longer wavelengths of light are better because they don't really see into the red part of the spectrum. So UV and blue is usually bad. However, there are hundreds of species of beetles that use red as their own secret communication pathway, right? And so if you put red out, you're going to be helping a lot of insects, but you're going to be hurting a lot of beetles, especially the charismatic fireflies that we all care about. And a lot of them actually do flash in those longer wavelengths of light, the yellow and oranges. So this will impact them. Of course, a lot of birds are actually impacted by longer wavelengths of light. And birds are weird. It just depends on time of year, which species, whether you're near the coast or not. And there's the point being, right? Biodiversity has, because of all the biodiversity, we do have all these different visual niches that have been fulfilled. So all wavelengths of light are going to be important. And so, yeah, there's unfortunately no specific answer. What I was referring to, though, is that for astronomy or the physics of light, if you have longer wavelengths of light, they're less likely to be spread farther in the environment. And so that's why a lot of places that are focused on astronomy will have red lights or amber lights. And overall, restricting your wavelength is better than not restricting your wavelength. So just saying, oh, no matter what, there's someone that's going to be affected by this, we'll just do white light. No, don't do that, because now you're going to be affecting everything. But so yeah, go with an amber. And when the fireflies are coming out, turn off your lights, right? Don't have any lights when the fireflies are courting. I think
you'll be able to see
Jenny
them better
wants to
anyway.
add
That's good for everybody.
Right. Yeah,
My dog's all getting all excited now. She likes the conversation. So you're saying that the amber lights are probably a better choice for people's homes and for maybe city ordinances and that sort of thing. Maybe not going to be helpful for all the animals, but at least it's a smaller range that is going to be affected.
So for our own human health, amber is by far the best. And very quickly, the reason is because blue light triggers or fires our melanopsin in our eye, which then leads to all these hormonal cascades that are telling us that it's daytime, right? And so during the night, we need to be told by our eyes that it's nighttime. The way to do that is make sure you have no blue light coming in. So blue light is bad at night, right? That's why you should not have you should have blue light turned off on your phone. You should try to minimize the amount of blue lights coming through TV and computers at night. It is bad. And the more and more we understand this from a human perspective, the more likely, or the more we're probably going to understand of its interactions with cancer and all the obesity, all these things. So again, I would say amber because it's better for humans for sure. And just if you're in a sensitive habitat where you have beetles or some other animals, birds, right, shorebirds, you need to pay attention to what light you're using. But really, if you're in those sensitive habitats, you probably shouldn't have any light.
Yeah, I mean, I agree. And birds are diurnal. Not all birds. The birds I study are mostly diurnal, and I think would react similarly to having a negative effect of bluish lights. And so one thing I know Brett has been studying and others in our field is this change from these oranger lights, or these old-fashioned lights, to these LED lights. And these LED lights put out more of this blue light, and we're seeing negative effects of that. So even though we're saving energy, we're actually creating more problems for the organisms and ourselves that are getting more of this blue light into our daily routine.
That's interesting. So for humans, maybe it'd be good to have like more blue lights in the bathroom or something in the morning to help wake you up. But you definitely want to keep those lights off in your house the rest of the time. And we're animals, so that's true for maybe most other animals as well.
Yeah, and I've talked to some engineers, and they're actually coming up with really cool ideas. I don't know if this is actually healthy, but the idea is like truck drivers, right, or pilots who are doing the long continental flights, right? At night, if you could actually have a little blue light that's coming and just on their eyes, not distracting, but just giving them the blue light. So it's like a natural caffeine. Now, how much that's going to affect in the long run, we don't know, right? I did mention there's this cancer trade-off, but that's the idea, right? And in the morning, blue light is immense. And of course, people in Norway and Alaska have been they look at blue light lamps in the morning during the winter when it's completely black and not waking up and depression.
It's a good segue into other behavioral consequences of light. And what are you finding that it means for birds or other animals that you're studying?
I look at both noise and light, and I look at them separately, and I look at their combined effects, because oftentimes we start studying one thing, like just the effect of noise on a bird or just the effect of light on a bird. But in these birds that live in more urban areas, they're usually dealing with both. And so one of my main studies is out in this pinyon juniper forest out in New Mexico. So it's not a city, but I can have these different treatments of light alone, noise alone, and noise and light combined, and control plots that are dark and quiet. And what we're seeing in terms of what are the actual fitness consequences is there's some interesting dynamics with our preliminary data. So it really depends on the life history of the bird and whether they're more sensitive or more of a specialist species versus a more generalist species. For example, light seems to have a really negative effect on survival for open cup nesters. So these are birds that build a nest in a tree, the type of nest you would find in a bush or a tree, versus cavity nesters that they use an old woodpecker hole and they're, inside a tree. It's darker. So light doesn't seem to be affecting the survival of these cavity nesters, but for these open cup nesters, we're actually seeing a pretty strong decline in nest survival when they're near light. But they're not avoiding light. They seem to have this innate attraction towards it. So when you're thinking about managing biodiversity in urban parks, or maybe they're not urban parks, but they still get some sky glow from nearby human activity, we can predict which species might be more affected and perhaps manage or at least try to reduce our light usage in certain areas where we know certain sensitive species might be nesting. A lot of moving parts. Things like noise, which can have negative effects in terms of stress, just like light can. When you look at actual nest outcomes, we often see a actual increase in survival because predators are having a harder time finding those nests. So there's upsides and there's downsides. If you can tolerate living in a noisy area, you might be more stressed out, maybe sleeping less, but your offspring are surviving. That's a trade-off of living in a bright and noisy world.
Yeah. And do you think that there's enough time? I mean, people always say, well, it's going to be great because eventually animals will get used to it. And like you said, with the moths, maybe you'll start to be picking genetically for one trait versus another. And so maybe those birds and noise just won't bother them as much, or they get louder voices as they genetically modify. But the changes that humans have made have been so rapid that it doesn't really leave time for most animals to really dramatically change their genetics. Or has there been enough time? Because, I mean, I suppose with insects, they don't live that long anyway. So maybe that sort of genetic and behavior modification happens more rapidly.
Yeah. So it's genetically, I don't know if we have, or correct me if I'm forgetting a study, I don't know if we have any really good genetic studies shown, but certainly there's behavioral adaptations, like birds adjusting their song frequencies or song amplitudes to be heard in the urban areas. But at some point, there's always going to be a physical limitation, right? At some point, you can't scream any louder. And so for some birds, that might happen a lot sooner based on what their vocalization range is, right? And so that's where you start to see this homogenization of diversity of species in these sensory polluted areas. Birds that are more generalists, that can eat lots of different things, that maybe have a wider range of vocalizations, they can adapt behaviorally and persist in these areas. But these species that just phylogenetically are unable to cope even over time, those are the ones that are going to start disappearing from these sensory polluted areas. So even if our protected areas like national parks, if they still have sensory pollution, even though to our human eye it's like, oh yeah, pretty good habitat, it could actually be pretty habitat degraded because of these sensory pollutants. And that's where you start to see that decline. And that's where, from a conservation perspective, you need to be worried, or at least taking into account our light and noise pollution levels in these types of areas.
The town I'm in, too, some of the protected, quotes, protected wetland areas in town run right past the freeway. And if you walk through those areas, it is so loud. You think, yes, all the plants are here and there's no roads, but the lights are right there by the road. The sound is right there by the road. In some cases, it's insanely loud. It's not at all relaxing to walk through that park.
Yeah, I think a lot of our green spaces in cities are that exactly, right? So they might be next to a water body and you have a thin strip of habitat, but the noise and light is actually quite high.
Have you been to Issaquah? You basically just described it. Yeah, that's exactly what it's like. It's like
No.
a beautiful lake, this little strip of land that's like protected wetland, and then the freeway.
Yeah, exactly. But just San Francisco is one of my main sites, which is very much so like that. And San Antonio, where I just came from, and I'm still doing some studies, and it's the same thing. So you have the San Antonio River going through town. There's a beautiful bike path. There's beautiful green habitat. And birds are still coming. And that's one of my questions. That's what I'm trying to study. What allows them to persist? And when does it become too loud or too bright where you stop seeing certain species? And how can we mitigate for that? Or can we improve the habitat in any way to try and keep these birds here instead of losing them? San Antonio is designated what they call a bird city USA because it has such high diversity. But if we're not paying attention, we're going to lose that diversity over time. So we need to be making sure we're taking all of the factors into consideration, not just making sure we have green spaces.
So I want to get into spider personalities because you brought that up, and now I need to know how much personality a spider actually has. And we name the spiders in our house because it keeps my daughters from being afraid of them. So we've got David, who lives upstairs right now on the fern, and it freaks them out when they first see him. They're like, oh, right, it's David. It's fine. So he's our little jumping spider pet at the moment who lives in the living room. But he doesn't, so much that I've noticed, have much of a personality, though he does seem to be a bit of an explorer. I'm sure there's more than one jumping spider in our house, but based on him going back to the fern regularly and having his webs kind of spread out from this fern, I think that's his main area or her main area. You know, I don't want to assume. But what kind of personalities are you talking about when you say that word?
Well, first of all, I love that you're naming the spiders, and especially that you're teaching your young kids to appreciate spiders. That's fantastic. I would challenge everyone to just go and name one spider that they're going to protect for a week. That would be so awesome. I love it. And I love David. More than one David, but this sounds great.
Yeah. We have Marius as well. Marius lives in the kitchen.
Awesome. And what kind of spider is Marius?
I think they're both jumping spiders. Like we seem to get a lot this time of year. Yeah.
Yeah. It's a good time to have jumping spiders. They're eating a lot of your fruit flies, your banana flies, and other things. So that's awesome. Yeah. So you said something that's really interesting, right? That your spider probably doesn't have much of a personality. That in itself is a personality. Again, I'm using air quotes. So the way we like to think of it as animal behaviorists is not necessarily like a personality, like how we think of it as humans, but more of these traits that basically go together, these behavioral traits that are correlated with each other. So you'll have more of a bold, aggressive jumping spider compared to perhaps a more timid or less active spider. And these are what we really call behavioral syndromes. And the key here is just that
I'm going to use that with my daughters in future. Your behavioral syndrome is not working for me right now. But
yeah.
I mean, is that the definition of a personality, though? You basically just define personality and then don't want to call it a personality, which I think is hilarious. It's very scientific of you.
And that's, I told one of my PhD advisors that I did the air quotes because I knew he was going to lose it.
Right.
And he did. He got so upset that we said personality. And the problem with personality is the person part, right? Like so you got to be careful about the anthropomorphization and all that stuff. But unfortunately for you, right? If your child is having a bad behavioral syndrome, well, by definition, like they're not going to get out of it. They're always going to have that behavioral syndrome because the behavioral syndrome has to be consistent across time. So you put them in different environments and yet they're still going to show that kind of behavior. And yeah, personality is just a bad word. We should have a different thing that's more inclusive to all organisms.
Because we don't call spiders spider people. They're spider people living upstairs. It sort of has a different connotation. Nobody wants to visit your house anymore.
People are starting to call dogs people, right? Like, oh, yeah. Someone said like one of my dogs is a real people person. It's like, I'm not so sure if that's correct, but yeah. So the spider personality though, right? We're looking at the differences in their visual traits and whether that corresponds with them being perhaps more aggressive, more bold. The idea being that these are nocturnal spiders, right? These wolf spiders. So if you have bigger eyes, and perhaps you're a bigger spider with bigger eyes, you're more likely to gain more light, and you're more likely to have more information about your environment. And thus you can be more bold. You can be more exploratory, right? Whereas if you have smaller eyes, you have less light, less information. You might want to be a little more timid. So we're trying to tease out this relationship in behavioral syndromes with their sensory environment, sensory traits. But yeah, it's not like we found like a funny spider yet, or a really mopey spider.
You've seen, I don't know if you've seen this lady on, I don't know if she's on Facebook or TikTok or what she does, but she has like pet spiders and they'll crawl into her hand and fall asleep. She has a picture of one like taking a nap in her hand. It is the freaking cutest thing I have ever seen.
No, I have not seen that.
And like it has followers and stuff. It really makes them, through this social media, you kind of see the spider and go, oh, okay, well, actually that's cute. That's adorable that it like tucks up its little front, I don't know what those are, arms, and then cuddles up and then falls asleep. And it's, I mean, you can't get much more cute than that when you're, except for the whole fact it's got 8 legs. It's pretty cute.
Can be.
But
I will be Googling this as soon as we're done with this.
Oh, you should. It's really cool. I'll have to link it in the show notes too so that people can see these spiders. It's adorable. So are you looking at this idea of behavioral syndromes for different species or for all in the same species of wolf spider? So different individuals will have different behavioral syndromes because of the size of that particular individual's eyes or because of the species size typically?
So behavioral syndromes and personality has to be within the same species.
Okay.
Right? It has to be. Otherwise, you're actually comparing oranges and apples, right? So the definition of behavioral syndromes is within the same species. And then what we're trying to do, and I should say that this is one of my more senior graduate students who's really interested in this line of work. So he's guiding it. But yeah, he's really interested in trying to understand which traits could actually predict different personalities.
Interesting.
And there's been a lot of work on quantifying different behavioral syndromes and perhaps some adaptive benefits to behavioral syndromes under different types, again, air quotes, of an individual. It hasn't really been investigated. So we're trying to look at the traits that could be explaining these different behavioral syndromes.
Do you find that is something that is affected by things like the light in the environment, or is this something that's outside of that other work that you are looking at?
No, that's what I'm trying to understand is how does the visual environment affect or select for these different behavioral syndromes? That's exactly what we're looking into is the light and the vision. And you'll have to come back and talk to me. Maybe you can talk to my graduate student in 2 years when he knows more.
What's the hypothesis? What do you actually think? Or what are some of the different variations that you're looking at and think that will affect it by?
So the main behavioral syndromes that he's looking at, right, are this tendency to be more exploratory or more bold. So going out in a novel environment, right? Another one is being aggressive. Another one is the voracity. So you give them a bunch of insects to feed on. How quickly do they do it? Are they a fast eater or a slow eater? And of course, all these are somewhat correlated, right? So if you're more likely to be exploratory, you're more likely to be bold. They're kind of all correlated, right? And this is where we call this behavioral syndrome. And so a lot of them they're not independent of one another. And I think the idea, at least one prediction, is that if you are bigger, have larger eyes, have more sensory information, you're more likely to be this more bold, aggressive individual. However, there's a counter hypothesis or counter prediction, and that would be perhaps you don't have as much sensory information. And so you're really aggressive, right? It's just a safer mode, just be really aggressive because you don't know what's going on. You don't have as much information. So you're just going to try to be aggressive. 2 different hypotheses here that both could make sense. We don't know. So we're collecting the data to see. Or maybe there's nothing that's going on.
Yeah, that is interesting. It seems like there could be quite a lot of factors involved in a behavioral syndrome too, in terms of just genetics and
the environment, right? And we do know with a lot of like mammals that the more bold individuals are the ones that are more likely in urban environments, the more exploratory individuals. So there's a lot of personality research explaining which animals are more likely to go into urban environments or interact with humans. So we'll have like the human wildlife interaction stuff. There's a lot of behavioral syndrome work there. I mean, I know you talked to Bruce Schulte, right, with his elephants. There's behavioral syndrome stuff there. They always have like a couple of these really randy, bold males that are coming in and destroying farms. I shouldn't say destroying. They're feeding. They're eating the food at the farms.
Yeah, the destroying is not the point, typically. Yeah.
They're not there to destroy. They're there to eat up food.
Yeah.
Yeah. And so there's a lot of research looking at how behavioral syndromes result in different types of human-wildlife conflict.
So what would you, both of you, say would be the main takeaway? What you're teaching a 101 class on this. What would you want your students to take away?
Well, if I'm teaching animal behavior or wildlife ecology, I think the main take-home message is we are affecting these animals, right? It's our light and noise pollution affects them at the behavioral level. It affects their within species interactions where, like he was saying, with insects and in birds, we see the same and expect the same things, where birds would be bolder or more aggressive in cities versus rural areas. And for birds that communicate acoustically, at least, we expect that to be because they can't hear each other, right? So if you can't hear what the guy across the bar is saying to you and he looks aggressive, you're just going to start fighting because you're assuming that he said something nasty to you. And so if in these noisy environments, these animals are persisting, we're going to see increased conflict, probably smaller territories, more fights, and potentially lower fitness over time. And so it's not immediately obvious that sensory pollution can have fitness outcomes per se, but it's a buildup of all these small effects that can lead to these declines over time in populations, whether it's birds or insects or any type of animal. So
we have the issue with orcas up here in the sound and the sound of the boats going past. It's a big area of research here in the Northwest at the moment.
Exactly. Yeah. So yeah, I guess take home message is we're here living in our world, but we need to consider the impacts it has on other animals. We're not the only ones here, I guess, would be my, if you learn nothing else, hopefully they remember that at the end of the semester. And let's hear what Brett has to say.
Yeah, I completely agree with that. And I would add, so Jenny, she studies more than one sensory modality, whereas I pretty much focus on light. And my take-home message would be simply to say, light is incredibly important and darkness is incredibly important. And the reason they're incredibly important is because animals have been evolving in these consistent cycles over hundreds of millions of years where there is daytime and there's nighttime, right? And that length might actually change based on seasonality, but it's been consistent. And these animals have evolved to either focus on one condition, maybe they're diurnal, right? So they're focusing during daytime, or perhaps they're nocturnal, right? And they need that. Just like we need our daylight, they need their nighttime conditions. And we have completely disrupted that. And we're continuously disrupting that. And that's going to have major consequences for everything that's living on this planet. So my take home is that the natural light and dark cycles are incredibly important and need to be seen as a resource. We need to protect these resources so that all the living things on this planet can continue to take advantage of the niche in which they evolved for. That would be my take home. And I would also say LEDs are actually, this is what I wanted to say. I agree about the LEDs, right? That most LEDs are blue light. However, LEDs can be any color you want them to be, right? We can control any color. So LEDs, if you just bought LEDs, don't think that they're necessarily bad. Check what color they are. If they're amber, they're still good. Get LEDs where you can actually change the color. And it's now very simple. You can choose a bunch of different colors of LEDs. And that way you can have the same light bulb be blue in the morning and then amber at night, right? They're totally the solution to this problem.
Yeah, my husband loves them. He's been putting them in all the lights in our house. And the kids were like, Alexa, play disco. And the light comes on and it just flashes like it's insane. And then they invite me to their disco party, which I then have to attend.
Yeah, my nephew really liked blue light, and I told him like you can only have blue light up to like 7 p.m. And then he's like, no, and I'm like, but if you're good, right, then I can wake you up tomorrow at 6 a.m. with blue light. And for whatever reason, he was excited about that. So
Yeah, it is funny what they get excited about. So if there was a book that you could gift to all of the listeners, what would that book be, Brett?
yeah, so I'm looking at it. It is The Darkness Manifesto by Johann Ekla. It's a fantastic book. It was published, I want to say 2 years ago, a year and a half ago. And it's written by a bat biologist who is really interested in the idea of light pollution in bats, but then it just spans. And so he grows from his own personal experiences with bats and light pollution to everything. And it also does a really good job of intertwining the changing of lights across Sweden over the last 100 years. So he's Swedish, does some really fantastic history of Swedish people and light pollution, with it all being under this ecological preface. It's absolutely fantastic. It's a wonderful like bedtime read, and you'll learn a lot about light pollution and just ecology and animal behavior. It's wonderful.
That's great. That sounds really good. Thank you. Jenny, what book have you got for us?
My book choice is Wildscape by Nancy Lawson. And I think you've had her on the show before. So I just thought for a person who's not a scientist, she does a really good job at summarizing the soundscape and how animals perceive their world and what we can do as individuals to try and create more natural soundscapes or landscapes, even in our what we can control easily, our own backyard. As Brett said, he's more of a light guy. I study both light and noise, but I definitely started out more so in the bioacoustics realm.
I would love for everyone to read that book and really look at their own living space, whether it's an apartment or a big backyard, and be able to think about how their own behavior is affecting their backyard wildlife, their little local environments.
Yeah, your microhabitat.
Yeah.
You can at least control that.
Yeah. Would you like to share a first memory of your connection with animals?
Sure, I can go first. Probably the earliest memory I have of animals is I grew up in the country in Central California, so surrounded by ag fields, and my parents were taking a field biology course at the community college. And so when I was 1-2 years old, they would take me on all these field trips across different habitats in California. Although the moment that stands out in my mind is just finding toads and snakes in our yard as a little kid and playing with them. And then of course we had our family dog. And so I loved just pretending I was a dog with the family dog and roaming the fields on my own. And our neighbors also had horses. So that started a lifelong obsession with horses, I think. So there's different layers. There's wildlife and domestic animals that really I was exposed to at an early age that just made me love animals.
Yeah, that's nice. That's nice. My girls found a newt the other day. They were super excited about that. We had weirdly unseasonably warm weather, and all of the frogs and the salamanders woke up very early this year and haven't gone to bed yet. But I think that they probably should go back to bed because it's going to get cold again. I don't know.
Oh, yeah. Yeah, it's definitely cold here in Washington. But yeah, we had that same warm snap.
That spike,
in Eastern Washington. Yeah.
Yeah, that was weird. And Brett, how about you? What's your earlier formative memory?
I always liked animals, right? My mom always said that I was going to be a zookeeper or a park ranger or a veterinarian. I became an animal behaviorist. But I don't know. I'm trying to think of all of my earliest memories. Of course, I was always fascinated by any living thing. But the one that always keeps coming to mind are all of my friends who, speaking of personalities, they always wanted to touch everything, right? So they're always grabbing everything. Whether it was a spider or a snake or a frog or a fish. And all of my memories going back probably till between like 3 and 6 years old was me always thinking like, why do you have to always touch everything? Right? Like, why can't you just, and I'm still that way as a biologist. Most of my buddies are going on grabbing stuff. I'm like, you just watch it. Like, why do you have to touch everything? And so, I don't know, my memories that keep popping up are me just being upset with my closest friends or my brother, always grabbing everything, right? Like having a toad in their hand, and you can tell this toad is just stressed out, right?
Mm-hmm.
It's just, you feel terrible for it. And that's most of my formative memories are just looking at these poor animals who are being held, right? They were just ripped out of their home. For me, that's what I was thinking, right? Ripped out of their home and put in a bucket for us to look at for some reason, where it's, I'd much rather look at them where they were, like by the tree, right? But that was all of my memories right now. And I haven't thought about this for a long time. But yeah, it's just not touching things. That was my idea, is like, let's just look at it. I remember at one time I dressed up, I think I was probably in third grade. I dressed up as a hunter / G.I. Joe, and I took my dad's camera and I went and just tried to film deer for like 2 hours, right? And the person was very afraid that I was going to be shooting this deer. But I don't have a camera. Again, never wanted to touch it. I don't really like touching things. And yeah, those are my memories. It's just trying to watch stuff and not mess with it.
Yeah, like, hold on, Steve Irwin, just put that frog down.
Yeah,
like,
exactly. Just leave it. Let it be.
Don't need to go touching everything.
To come over and grab you, right? Like, just knock it off.
Yeah, it's like an alien abduction. So you're anti-alien abduction.
That's great. All right. So, Brett, what's the deal with animals?
Oh, man, deal with animals. I love this question. So I think my very flippant answer would be they're just doing the best they can. So they've acquired traits for specific conditions, and they're doing the best they can with those traits to survive, reproduce, just like everything else. And unfortunately, a lot of that stuff's changing. So they have traits that might not actually be the best for their current environments, right? So they're coping the best they can. That's the
You took my answer, Brett.
What first?
Yeah. Yeah, I think that's very much a biologist's answer. The deal with animals is they're just trying to survive each day, right? They're trying to get food, water, shelter. They're trying to survive for themselves and their offspring, and just try not to get killed by something else. So I think the deal with animals, or the deal with humans, is if we're so smart, we should at least try to use that intelligence to help the other creatures around us, make our ecosystems better and not worse.
That was Dr. Jenny Phillips from Washington State University, go Cougs, and Dr. Brett Seymour of the University of Texas, El Paso. If you're enjoying this series so far, please take a moment between episodes and write a review on your listening platform. And let us know about your favorite episode or series of The Deal with Animals. The feedback is incredibly useful, and I love hearing from you. Thank you for joining me as we try to answer the question, what's the deal with animals? I'm your host, Marika S. The theme music for The Deal with Animals was composed by Kai Stranskoff. And thank you as well to Christina Blanco for behind-the-scenes help with social media, bonus content, and our Patreon page. You can see links to the guest book recommendations, as well as their websites and affiliated organizations in our show notes and at thedealwithanimals.com. This podcast was produced on both historical tribal land of the Snoqualmie and Quinault Indian Nations. For more information, go to the Snoqualmie tribe's ancestral lands movement.
So what do you think is the deal with animals?
The Deal with Animals is part of the iRoar Animal Podcast Network.
That was The Deal with Animals with Marika S.
For more great iRoar podcasts, visit iroarpod.com. That's IROARPOD.com.